Okay, in lesson 14, we're still dividing, but we're dividing with regrouping. And the first one here they've already done for us as far as doing the regrouping. So I'm just going to show the standard algorithm and how it relates to it. You can see on the standard it says 3 and 5, and that represents right here the 5. 3 goes into 5 one time, and that shows that we've got 1 in each group. And then in order to find out what was used, we can see down here that we used 3 in regrouping. 1 times 3 gives us 3, and we have to subtract that from our total. And we have 2 remaining, and that shows the 2 remaining up top. The 2 remaining has to be regrouped, and that's 20 we're bringing over to the tenths. We already have 2 tenths in there, so you can see when we bring it back down on the standard algorithm, we actually had 22. Now, using a standard algorithm, we say 3 will go into 22 7 times. And that's shown right here in the tenths. They were able to split 7 up in each one. And 7 times 3 gives us 21. They were able to use 21 of those. And that's why they have 1 left over right here, which they had to regroup. When they regroup, that gave us 14 in our hundredth spot. So 3 are going to 14 4 times, because 3 times 4 is 12, and they used 12 of them. So they're subtracted 12 from our total, and we ended up with 2 remaining, which is showing right here. Then they had to regroup those 10. And when they bring it down, they ended up with 21 in thousands. 3 going to 21 7 times. 7 times 3 is 21. And we have nothing remaining. And the second one's not done for us, so the first thing we're going to do is we're going to model it. And the first one's 5 ones. We have 3 tenths. We have 7 hundredths. And we have 2 thousandths. Now it says we're dividing into 4 groups, so I'm going to make 4 groups down below. Now the first thing we're doing is seeing how many of the ones we can split into the group. We end up with 1, 2, 3, 4. So we used 1, 2, 3, 4, and we have 1 remaining. Over in standard algorithm, we say 4 we're going to 5 one time, which is shows the same as this one group right here. And we used 4 of them, so we subtract that, and we have 1 remaining. Now one thing you have to remember is put the decimal in your answer exactly where it is in the problem. Now our next step is we have to regroup this 10 over, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's the same as bringing down our tenths. We have 13, which if you count the tenths, we'd have 13 dots in here. Now we're going to split up to 13 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we were able to use 12 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have 1 remaining again. On the standard algorithm, we look at 4 going to 13 3 times. As you can see, 3 in each group. 3 times 4 is 12. We use 12, and we have 1/10 remaining. But we're going to regroup that tenth to hundredths, and there's 10 hundredths and 1/10. That's 4, 5, 6, 7, 8, 9, and 10. When we bring our 7 down in our standard algorithm, now we should have 17 hundredths, which we counted 10, 12, 14, 16, 17. So it works out. Now we're going to divide up the 17 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we are not going to be able to use all of them. We're using 16, and we're going to have 1 to regroup. And there's our 1 to regroup. And you can see the standard 4 goes into 17 4 times, because 4 times 4 is 16, which left us 1 left over, which is we're showing right here. Now we're going to bring that over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When we bring down our 2, we show that we have 12 in our thousands, which we do. Now we're going to split up our thousands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we used all of them. So we have 12 hundredths and with a remainder of 0. And the 4 goes into 12 3 times, giving us 1 and 343 thousandths. Now we're going to work just with the standard algorithm. When we write the standard algorithm, the dividend goes inside the bracket, and the divisor is outside the bracket. So the biggest misconception is to read this as 4 divided by 64 hundredths, because it's actually 64 hundredths divided by 4. Now the first thing we would do is say 4 will go into 0 ones. Well, it goes 0 times. So now we're going to go to the next place value. So 4 will go into 6 tenths 1 time. 1 times 4 would be 4. So we've used 4 of the 6 tenths up, leaving us 2 tenths. Well, we can't put 4 into 2, so we're going to regroup, and now we have 24 hundredths. 4 we're going to 24 hundredths 6 times. 6 times 4 is 24, and it shows we've used all of it. Now to double check my answer, it's always good to do the opposite operation, would be multiplication. So if I multiply my quotient, my answer, times my divisor, I should end up with my dividend. 4 times 6 is 24. Here are my 2. 4 times 1 is 4, and 2 is 6. 4 times 0 is 0. Now I know this is almost 0, so I know my answer would have to be less than 1. So the reasonableness says it should be 0 and 64 hundredths, which I have the same answer. Going to the B, once again, we're going to write in our dividend. And we're going to start off by saying 5 will go into 6 1 time. Now we have to subtract what we've used. 1 times 5 is 5. We have we have 1 1 left over. Put our decimal place in position. We bring down our next, which are our 4 tenths. Now we have 14 tenths. And we know that 5 will go into 14 tenths 2 times. 2 times 5 is 10. And we have 4 tenths left over. We're going to regroup to 45 hundredths. 5 will go into 45 9 times. 9 times 5 is 45, showing that we have nothing left over. Let's check our answer. 1 and 29 hundredths times 5. 9 times 5 is 45. 5 times 2 is 10, and 4 is 14. 5 times 1 is 5, and 1 is 6. And we can see 1 times 5 would be 5, so the most reasonable answer would be 6 and 45 hundredths. Matches. On C, our last one, we have 16 and 404 thousandths. And we're dividing by 6. 6 cannot go into 1. 6 cannot go into 1/10. So 6 can go into 16 ones 2 times. Put my decimal point there already. 2 times 6 is 12. So we can see we had 4 ones left over. We're going to regroup to our tenths. 6 will go into 44 tenths 7 times. 7 times 6 is 42. We're going to subtract, get 2. We're going to regroup again. Now we have 20 hundredths. 6 will go into 20 hundredths 3 times. 3 times 6 is 18. Leaving 2. We're going to regroup to our thousandths with our 4. And 6 will go into 24 4 times. 4 times 6 is 24. With 0. Let's go ahead and multiply it out to verify. 6 times 4 is 24. Carry a 2. 6 times 3 is 18, and 2 is 20. Carry a 2. 6 times 7 is 42, and 2 is 44. Carry a 4. 6 times 2 is 12, and 4 is 16. Now, this is closer to 3 here, so I'm going to go 3 times 6 would be 18. So we know our answer has to be 16 to 404 thousandths. 4. The total weight of 6 pieces of butter and a bag of sugar is 3.8 pounds. The weight of the bag of sugar is 1.4 pounds. What is the weight of each piece of butter? So let's start off by doing a tape diagram. And it says the sugar is 1.4 pounds. This is the sugar. Then it says it has 6 pieces of butter. So I'm going to go ahead and do, there's 1, there's 3, and 3. And it says all of this, including the sugar, was 3.8 pounds. So the first thing I need to do is find out how much the butter weighed. And I'm going to do that by taking 3.8 pounds and subtracting 1.4 pounds, which was the sugar, and that will give me my weight of butter. And once I have the weight of butter, I can divide that by 6 to find weight of each piece. So let's start off. I have 3 8/10, and I'm subtracting 1 4/10. So that's going to leave us with 2.4. So I know the butter here is 2.4 pounds. Now I need to take 2.4 pounds, and I'm going to divide that by 6. Move my decimal, write my answer. 6 cannot go into 2, so I got 0. 6 can go into 24/10 4 times. 4 times 6 is 24, and I've viewed it all. So each piece weighs 4/10 of a pound.